let's try this Pythagorean trig question. This is a good revision of grade 11 work. And we're going to use the grade 12 difference identities in doing it. So let's just try this. It says use the given ratios in the Cartesian plane. First, find the individual ratios, that these are trig functions ratios, of the compound angles. And don't solve for the angles with a calculator. It's without a calculator. So if you were given that there was this angle alpha and there was a sine, the sine of this angle was 4/5, but it's acute. That's another way of saying it's in the first quadrant because it's less than 90 degrees. But the beta, this angle here, makes a negative cosine between 0 and 180. That's got to be the second quadrant. Now, the first job you have to do is you've got to draw a couple of triangles. There's alpha in the first quadrant. I know sine is 4/5. Well, if I go 5 squared minus 4 squared and square root it, I know that's a Pythagorean triplet. So I know that that adjacent side must be 3 by Pythagoras. On the other side, I know that the cosine is adjacent over hypotenuse, negative 12/13. Hey, sine is positive here, and 13 squared minus 12 squared and square root it, you get 5. So now I know the opposite side of the triangle where beta is. The actual angle of beta is there, but the reference angle of beta is right there. So I'm calling beta right there. Okay, so now all you do is cosine of beta minus alpha. Well, what's that? Well, first, so the cosine of alpha must be 3/5, adjacent over hypotenuse, and the sine must be 5/13. Now that we know it, we just write down the formula. What's the cosine of the difference of two angles? Well, there it is. And all we do is put in the fractions. Put in the fractions and then multiply it out in our calculator in our head. That's going to be 20. That's going to be minus 36. When you add it, you get minus 16. On the bottom, there's 65. And that's it. The next question, it's the same thing. You got to do a little bit of work here. You've got to divide by 13. So the cosine is 5/13. But P is somewhere between 0 and 270 degrees. So cosine is positive, but it's between 0. There's only one place that can be, the first quadrant. Here, tangent is positive, but the sine is negative. Well, there's only one place that can happen, and that's the third quadrant. So that's why you need to draw your picture right here. The third quadrant is where the angle Q comes to, and there's the reference angle. We know the tangent is 8/15. Oh, what you'd have to do first, I should say, I said you've got to divide by 15. You've got to divide by 13 here. Add 8 and divide by 15, and then divide by 13. Where the angle P is, you're given that the cosine is 5/13. Well, by Pythagoras, 13 squared minus 5 squared, you get 12 there. And here, if you go minus 8 squared minus 5 squared, add them and take the square root, you get the hypotenuse here. Now you know everything about these triangles, so you can find something like the tangent of P. Go to P. What's the tangent? It's 12/5. What's the sine of Q? Well, go to Q. This is where the angle Q is. There's the reference angle. It's minus 8/17. Just put it in your calculator now. Go 17 times this over this. You get minus 96/5. There's the answer. Now, the same thing for the sine of P plus Q. There's the formula, sine, cos, cosine, and just fill in the fractions. 12/13. The sine of P, go to P, 12/13. The cosine of Q, adjacent over hypotenuse, minus 15/17. Do that for all of them. For the cos of P, just go to it, adjacent over hypotenuse, well, we're given that. But the sine of Q, that's minus 8/17. Just put it in your calculator now or work it out. That's minus 180. That's minus 40. Together it makes minus 220, and 13 times 17 is 221. The last question. It's just the same thing. The cos of P plus the cos of Q, put down the formula, and then go to the triangles and work the adjacent over hypotenuse for P and Q. Just fill in the fractions, put it in your calculator, and you'll get minus 171 over 221. And there you go. That's the whole thing